So, hello everyone, I am Prathamesh Saugale. I have graduated my BTech in Computer Engineering from PCCOE. You might not know. Okay, not not an issue. I have been interned at HSBC, and yeah, I have built in many stuffs out there. But right now, I am just having my tough time. Okay, no any issues for me, but for now, I'm looking to explain the explain threadings and its concepts of deadlock. We'll focus upon dining philosopher, which is an deadlock condition which occurs when n numbers of philosophers are given n numbers of folks. We'll understand it later. So let me open the Excel draw to understand it. Okay, that is what. Okay, that's the different plan out there. So okay, so consider here's the table you have got it, and let me have a pencil out here. Here is first, second, third, fourth, fifth, sixth, seven, and yeah, 8. So suppose there are 8 number of folks present here, means knife, fork, whatever you call it, and let us draw philosophers here. Let me copy this, paste it here, paste it here. Sorry, paste it here. Okay, so these are 8 philosophers, and let us also draw the plates. Not that nice, but okay, not an issue. So we are giving plates to every philosopher, so he might eat and his deal. Okay, so we have given 8 numbers of folks out here, and we have sat down uh, sat down 8 numbers of so 8 numbers of philosopher. So condition to it is philosopher should have 2 folks, either this or that, any one of any one of them that should be present with them. Okay, laser pointer. So if we consider this one, he should have these 2 folks to eat the meal. Same goes with this person, same goes with this person, this philosopher. So every philosopher should have 2 folks to eat. So okay, we got the problem. Now what is happening here? Suppose this philosopher want to eat. Suppose all philosopher want to eat. Everyone want to eat his meal. So what they will do? They will pick up their forks. He will pick up his. He will pick up his. He will pick up his. He will pick up his, and everyone simultaneously pick up their own food. So what is happening here is kind of they are not getting the second fork. Okay, so it's an major issue because they are, as the second person is not, any person is not getting the second fork, nobody will have, means nobody can eat, and it will cause the issue of starvation. So nobody can eat, so everybody will remain hungry, and it will cause a problem of starvation. So we understand what the problem is. So what are the solutions? So if we think logically, if this person is sitting out here, let him give two folks out. Let the philosopher beside him remain hungry for a while, and give just to the adjacent of hungry ones, all the folks. Same goes here. He will remain hungry and he will eat. After finishing both of them, 1 minute, I will. So after finishing his meal, they will get back their folks, and that is how everyone will get the meal, a meal to be meal to eat. Sorry, folks to eat. So we have now we understood the solution to. Is there any other solution? Yes. So okay, as everyone took its fork, let the last person stop for a while until first person eat. So what happens if this is the first person? He will take his forks, he will take his fork, he will take his fork, he will take his fork. Same goes here. But the last person was asking for this fork, but let us limit till here. So this person will not get fork and he will wait. So this person, as he have got this fork, he will acquire this fork and start eating. After completing eating, this person will get fork. This person will have eaten his meal, and this person will get two of his forks. So you will see the pattern, like he eats first. So first person will eat first meal, second person will eat second, and might be interchanging as how person have started eating meal. So this solves the problem. So we have to see in two ways. So okay, now how it is related to threadings. Suppose instead of philosopher, consider them as an okay, threads. Okay, let me consider them as threads. Okay, so philosophers are considered as a thread. So if there are 8 threads present out here, they will process parallelly, as there might be a CPU giving multiple cores and multiple threads out to process in parallel and concurrent way, which would enhance the speed. So this is so consider the philosopher as in threads and the folks as in resources. So these are resources that were needed from RAM to process the task. So threads are performing subtasks of a process, and they needed some resources to complete their task. Yeah, we as anyone needed a headphone, then it will perform. It will need an headphone to do its task. Means it. For an example, I'm giving. It will need an external or internal resource, whatever kind of resource he needed. He should get that resource, and if he doesn't get the resource, the task will not be completed. So this is how the deadlock condition occur in threads. So how it is related, so how the Dining philosopher is related to deadlock condition in thread. I have related to that. Considers the philosophers as threads, and um, you can consider food as a resource or any operation. And yep, these are resource. Folks are resource which were needed to complete the task. So okay, we have understood what has happened here. What is the solution? So let's get to the solution right now. Okay. mm, Let me attach my headphone. I might be audible for better understanding. Um, by the way, if you are wondering, so let's open online. Okay, hello world and blah blah blah. Let us include some libraries. stdio.h. This is first library for printing out any process. We are creating a simulation so you could understand what would we would we doing out here. Okay, unit study include semaphores as we needed and variable flag and fourth is thread thread.h. So these are the four library headers we are using out here. First of all, we'll use the we'll define number of philosopher present. So let us define it for 5. Okay, no worries, whatever number we can keep, 8, 5, 7. Will we have kept it as generic out here. We could change it as per we need. Let me take initialize semaphores. So what kind of semaphore we want? We want an limit semaphore which will limit to n minus 1 number of philosopher to eat the meal. So we are using limit semaphore. Semaphore is a variable, whereas mutex is a boolean, more like kind of boolean, which is an object. Okay, it could be null or it could be have lock or unlock. So we thread we are creating the mutex out here. So we could assign it to folks, as folks are can be taken or not be taken. So they have two conditions. So it is binary. So we could take semaphores, binary semaphores, or rather we stick with mutex. Both ways are good. No issues to do anyway. So we'll take folks of numpy size. Okay. So let us write the function for philosopher and void star r. Now I will explain what I am writing out here. So this is void data type which we are writing as we do not know what kind of data type it is being returning. So we are using void data type to to keep it generic and return any data type we wanted. Okay, so first of all, what we can do, we have semaphores and we have threads. So first of all, we'll check if it is matching the satisfying the limit as the limit. So to philosopher to
eat, it should first satisfy the limit of how many people can eat. So there are five numbers of philosophers. Then there should be four numbers of philosophers eating out there. So let me use wait. By reference, we are passing limit. Okay. So we have checked. Let me call post to as there is single semaphore right here, and after every event is been occurred, it should increment as anyone has completed his feast, then he should uh, tell the semaphore that he has completed the feed and the limit should be increased. For the simulation, we'll use printf the philosopher percent d is thinking. Okay, so which philosopher has been thinking we should pass it via ID. So let me define ID. What is ID? So we will pass an argument of what which philosopher is calling the function. So let me call int ID equal to okay okay int star. So you might be wondering what it is doing. So it is the typecasting as our have void data type. We are typecasting it to integer. So we'll pass integer in main function. So we can directly access the data out in integer from above below in from main function. So okay, so we got the ID which philosopher we are dealing with and which philosopher is thinking and which philosopher is eating out there. So first is satisfying condition. First of all will be thinking out there. Then in between they will be eating, and after that they will they will leave they will be completed and they will leave the dining table. Okay, so if eighth person is taking the meal, what should condition look like? Eighth person is eating. So if I is eating, he should grab first his fork and he should grab his other fork. So let me put out the condition, sorry, the function to to be measured here. So what is happening is fork fork ith fork and I plus fork is being locked out here as it is being used by ith person. So let me lock out the ith fork ID and thread mutex lock forks ID plus 1% numpy. Okay, so now ith person is eating right now. So we'll print as in simulation that okay he's been eating out here. Copy paste. Okay, eating. Let me copy this. Now if I person is completed eating, eated, eating. Let me have one 1 second. So considering in simulation, we will keep wait of 1 second. So it will wait 1 second to process to be completed. So let me paste out here. As process is completed, we'll unlock the fork. Okay, we have unlocked the fork, and okay, we'll copy this one, and yep, as eaten or completed is need. So okay, this is how philosopher's function is been looking. Let me write fast main function. Okay, so we have main function. First of all, we'll create threads of philosopher underscore t. So these are threads of philosophers. Let me create five number same numbers of philosopher. That numbers of uh, um, folks will be present out there. Second, we'll init the semaphores and mutex. So as we have mutex and semaphore, we'll initialize it. So we have one semaphore. So sem init, which is limit. Now I have told what limit starts and what limit it goes to 0 to num p minus 1. Okay, then we'll have for loop num p I plus plus. Okay, copy. Let me copy this. We will be needing this in more cases. So we have to initialize all the mutex. So yep, limit. Sorry, pthread mutex init. So initially and forks of I is null. So initially there is nothing in mutex, so we'll initialize with null. Now I have told we need lot more code. So first of all we have initialized. Second thing that we needed is to create a thread. So p thread create. So how we'll create the thread? We'll pass the thread that we are needing, which is philosopher, ith philosopher. What argument we need to pass? We need to pass null argument. What function is being passed in the thread? Then it's philosopher function. And now id, we are passing an argument as id. So let me create an array so we could pass it by reference. So there will be memory out there to pass it by reference. Okay, id of size numpy. So id of I, okay, id of I equal to I. So after creating threads, pthread, let me join the thread philosopher comma null. We do not need a any other for loop right now. Let me destroy the semaphore after using it. What was semaphore named? Limit. Limit. So okay, we have completed our task to destroy the limit. Let me run and understand any issues are there. So okay, first of all we got the first issue. Okay, we will understand what happened. Okay, we have to pass by reference, but we have passed directly. So yeah, the mistakes can happen many. Okay, let me check if there is any other issue. Limit and limit. Okay, no issue. Okay, sorry, it's not philosopher, it's philosophical thread of I. It is and okay. We should pass by reference to. Okay, it's working, but let me check what is happening out here. Slashing. Okay, let me copy, paste, paste, and run the code. So, okay, zero start thinking, zero start eating, one start thinking, three start drinking, three start eating, four start thinking, and two start thinking. Yep, okay, zero and three completed. Now one can and one and four can eat. One and four completed. Two started eating. Okay, it is working fine. And this is what code look like of dining philosopher. Simple 56 line of code. Let me join the thread. So this is an overview how we can solve the dynamic philosopher problem and how it has been solved through thread and how easy it is to write and thread. So this is the overview and simplified version. And hope if you like, you can ask any question out and any question out how it is done and how internal working of operating system has been done out. For now we'll wrap up. Thank you for